Okay, I'd like to talk about adding and subtracting measurements or approximate numbers. And noticing the directions here, remember when adding or subtracting, you round to the least decimal place. And when multiplying and dividing, you round to the least number of significant digits. And this is very important. This is how you're going to perform these operations. So I look at number, and what I like to do is I like to look at number 8, and first of all, I like to decide how I'm going to round it. That way I've already made that decision. So I'm adding and subtracting, so I round to the least decimal place. So this is 1 decimal place, that's 3, and that's 2. So I'm going to round to 1 decimal. Now I'm going to pick up my calculator and I'm going to add these. 5.6 plus 0.681 plus 88.04. And I get my answer, and I just like to write it down before I round. Now I'm going to round. I'm supposed to round to 1 decimal place. Well, there's the first decimal place. That number's a 2, so I drop. So the answer is 94.3, rounded to 1 decimal place. I'll let you do number 9, but noticing here again, 1 decimal place, 3, and 2. So on this one, you would round to 1 decimal. Oh, I've got to make an apology. I was supposed to subtract. Let me redo that one. 5.6 minus 0.681 plus 88.04. Sorry about that. I'm sorry. I get 92.959. So my first decimal place is here. So that number after that is a 5, bigger. I'm going to round that 9 to a 10, so I'll put 93.0. It is very important that you put the 0 there because that shows where you rounded to. On this next one, number 9, there's 1 decimal, 3 decimals, 2 decimals. I'll round to 1 decimal. I'll let you work on that one yourself. When you multiply or divide, you round to the least number of significant digits. This first number here, 1.49, has 3 significant digits. The second number here, 93.15, has 4. So I'm going to round to 3 significant digits. I like to make that determination before I even start the problem. And then I'll do 1.49 times 93.15. And again, I'm going to write the whole answer down, just what appears on my calculator. But we're rounding because these are measurements, so we don't know how close they are to the true. So I have 3 significant digits. So the 3 significant digits are these 3. But I look here and there's a 7, so that makes that 8 and 9. So the answer is 139. Okay, moving on down, we want to talk about scientific and decimal notation. Actually, I'd like to talk about number 14 first. We want to express numbers in scientific notation. Scientific notation is a shorthand way of writing very large or very small numbers. And it's you can imagine, and it actually has happened, if you had to write the number 36,000 over and over, you might get careless and forget a 0. Even if you were typing it, it could happen. But if we write in scientific form, it's more, we're keeping track of the place values better. So I look at this, and to put another number in scientific form, I'll just do it and then I'll give you the definition. I move the decimal behind the first significant digit. So that would be 3.6 times. Now, our number system is based on 10, and every time I made that number smaller, right? Every time I move one place, I'm dividing by 10. I divided by 10 once, 2, 3, 4. I divided by 10 4 times. So to reconstitute that number to get the value, I have to multiply by 10 to the 4th. So that is answer C. In general, in scientific notation, it's in the form A times 10 to the n, where A is a number that's between 1 and 10. A can't be 10. It can be 1. It cannot be 10. And then the n is an integer. It can't be a fraction or anything. So let's look at number 15. I look at this number. I want to write it in scientific notation. So I look at that. I'm going to move my decimal to behind the first significant digit, which is 7.1902. Now, how many places did I move that number? 1, 2, 3, 4, 5, 6, 7. Every time I move that number one place to the right, I multiplied by 10. So to counterbalance that, I need to divide by 10 or multiply by 10 to the negative 7. 10 to the negative exponent means divide. So the correct answer for that is D, 7.1902 times 10 to the negative 7. Looking back up here at number 11 then, this is a number that's in scientific form, and I want to take it out. Now, I'm left-handed, so I get my right and left confused. I don't know if there's any other lefties out there watching this. Maybe you have that same problem, maybe you don't. But it's hard if you read the directions, it says if the exponent's negative, you move the decimal to the left, and if the exponent's positive, you move the exponent to the right. That's hard for me to remember, and it makes it easier for me that I know if I have a negative exponent, the number's going to get smaller. Smaller meaning smaller than 1. So all I need to do, I look at this number, I'm going to make it smaller. So it's the decimal point's going to go to the left. But I just think of it as making the number smaller. Now, I need to get the number back, I need to move the decimal 6 places to the left. The first place is going to jump in front of that 7, and then I'll have 5 zeros. So I'll have 5 zeros, and then 7197. And that is answer D. Let's do another one of those. Using my same idea here, I look at 3 times 10 to the 5th. That's a positive exponent, so that number is going to get bigger. So my number 3 is here, the decimal's here, and I'm going to move the decimal 5 places to the right. I'm going to multiply by 10 5 times, a 1 and a 2 and a 3 and a 4 and a 5. So that means I'm going to add 5 zeros, and my number's getting bigger, and my number is C, 300,000. So I'll let you try number 13 as well. On the next page, we talk about multiplying numbers in scientific form. And when you multiply numbers in scientific form, you multiply the whole number parts, or the number parts, just like you multiply. But when you multiply powers of 10, you add the exponents. And when you divide powers of 10, you subtract the exponents. So this problem is multiplying. So notice it's 4 times 10 to the 8th times 5 times 10 to the negative 6. There's a property in math called the commutative property, which allows me to reorder the multiplication, and I'm going to change the order around. I'm going to make it 4 times 5 times 10 to the 8th times 10 to the negative 6. Now 4 times 5, easy peasy, that's 20. Then I multiply 10 to the 8th times 10 to the negative 6, but when I multiply powers of 10, I add exponents. If I add the 10 to the 8th minus 8 plus negative 6, that's 20 times 10 to the 2nd. That's 20 times 100. That is 2,000. Now this next part was a lot of the lecture last night on our Zoom session. And this is to use dimensional analysis to convert the quantity. Now, when you talk about dimensional analysis, I'm just going to take a minute to talk about what I call a unit fraction. A unit fraction has 2 properties. It equals 1, and the numerator and denominator are different units. So for example, on this problem, 36 inches is a yard. So since I know that 36 inches is the same as 1 yard, they're the same thing. Anything over itself is 1. Anything over itself is 1. So I'm going to use a unit fraction to do the conversion. And the real trick, if there is a trick, it's not a trick, is to figure out which unit goes in the bottom and which unit goes in the top. So let me show you this problem. I have 24 inches. And I like to write that over just a generic one to get it popped up in the numerator. And this is my unit fraction I'm going to create. Now, I want to multiply and I want to get rid of inches. So if I have inches in the top here, I have to have inches in the bottom there, so they'll cancel. So that means I'd have yards in the top here. Now, I know that 1 yard is 36 inches. And then I would multiply. I would reduce the inches out. They cancel out. So now that gives me 24 times 1, or 24 over 36 yards. And then what I'm going to do is divide that out and change it to, I'm going to round to 2 decimal places, 0.67 yards. So this is called dimensional analysis, or using a unit fraction to convert. let me do another one down here with number 22, and then I'll come back up and talk about metrics. 22. 22, I have 8 centimeters to inches, and I'm told that 1 inch is 2.54 centimeters. So I want to use a unit fraction. I'm going to have 8 centimeters over 1 times. Now, because I want to get rid of centimeters, centimeters go in the denominator, inches go in the top. And then I look at my numbers. Now, there are a few people I've seen that do this, and they get the numbers messed up. But look at it. It's 1 inch. 1 goes with inch. 2.54 goes with centimeters. And then I multiply across. 8 times 1 is 8. 2.54 times 1 is 2.54. Centimeters cancel, so I'm at inches. And then I divide it out. 8 divided by 2.54, and that rounded off is 3.15 inches. Now, I have, we talk about the metric system. The dimensional analysis works. You can use dimensional analysis anytime you need to convert. Always works. Always works. But there is a shorter way, and let me show you this in the metric system. Okay, in the metric system, first of all, I want to mention to you that every major industrialized company in the world except the USA is totally metric. The USA is not, but we have a lot of things that are metric. And if you look at the PowerPoints in Newton, in the one slide, they list the 6 metric prefixes and the values. So the 6 metric prefixes are kilo, hecto, deca, and then I'm going to put unit, and then deci, centi, milli. Kilo means 1,000, hecto means 100, deca means 10, unit means 1, deci means 1/10, which I can write it like a decimal if I want. Centi means 100th, 0.01, and milli means 1,000th, or 0.001. Now, the word unit here, we're studying actually 4 measurements in the metric system. We're studying meters, which measures length, grams, which measures length, and liters, which measures capacity. Now, if I put a km, I mean kilometer. If I put a kg, I mean 1,000 grams. And if I put a kl, I mean 1,000 liters. So these prefixes, kilo, hecto, deca, deci, centi, milli, go on front of the base unit. So the unit could be meters, liters, grams. There's many other units in the metric system. And folks, there's many more prefixes. You've all heard of a terabyte, a gigabyte. Those are very big prefixes. They're more than a kilo. You've also probably heard of a micrometer or a microliter or a nanosecond. Those are very small, smaller than milli. But the 6 we're working with, just to get used to it, are kilo, hecto, deca, deci, centi, milli. And you can certainly feel free to go look up the other prefixes. So if I want to convert 6.32 decameters to 1 meter, then how I would do this with the using dimensional analysis is I would do 6.32 decameters, and there's 10 meters in a decameter. So 10 meters is 1 decameter. So I would write it like that. Decameters would cancel. I multiply across, and I'd have 632 meters. Sorry, 63.2 meters. 63.2 meters. But let me show you an easier way to do that. An easier way to do that is if you have your chart, and it's easy to make. And you say, I'm going from decameters to meters. That's one place. That means I'm going to multiply by 10 one time. Or I'm going to move my decimal 6.32. I'm going to move my decimal one place. So it's 63.22 meters. Generally, when I teach this, I show my students that you can use dimensional analysis with the metric system. But I go to this method because it's so much easier. Let me do one more like that. 6 grams to centigrams. I'll do it both ways. So first of all, if I look at centigrams, 1 centigram is 100th of a gram. Okay, that's my conversion. So I'm going to put 6 grams, and then 1/100th of a gram is 1 centigram. So the grams would cancel, and I'd have 6 divided by 0.01, which would be 0.06 centigrams. But an easier way to do that is to make my table kilogram, hectogram, decagram, gram, decigram, centigram, milligram, and then I write 6 grams. No, I did that wrong. Sorry about that. There are 100 centigrams in 1 gram. I did that backwards. So that should be 600. And then from grams to centigrams, I'm going to go 1, 2, 600 centigrams. Sorry about that. Hope that straightens that up. I have 6 grams, and I know that there's 100 centigrams in 1 gram. I don't know why I messed that up. 600 centigrams. And there's a couple other problems that you can try.